Welcome friends, in this video we're going to learn about locating points in three-dimensional space. So let me review what I've constructed here. Take a look. I built up basically like a model of a 3D coordinate system. That is called the origin, and the value of the x, y, and z's are 0 for each one there in the corner. Along this direction, that's the z coordinate, the way you see here. That's the z-axis, in other words, going straight up. That there is the y-axis going in this direction. And that there is the x-axis going in that direction, as you see here. Once you have this kind of coordinate system constructed, you can locate points in it pretty easily. Take a look. First, I'm just going to focus on this plane right here. This is a plane where I'm looking. And this is specifically the y-x coordinate plane. And it's called that because, you see, the value of the z-coordinate in this plane is 0. Take a look. When I look at it from this perspective, it's kind of like the thickness of a sheet. And even that is too thick. In real life, it's meant to basically have no thickness. So the value of the z-coordinate in this plane, anywhere, that's a plane, as you can see, is 0. To mark a point in there, take a look. I'm going to do it as follows. I have this point 750. I hope you can see that, 750. And to locate it, at first I observe that the 7 represents the x-coordinate, the 5 is the y-coordinate, and 0 is the z-coordinate. And I just count, that's all. So I'm going to count 7 along the x-axis, you see that? Then the 5 tells me I count 5 along the y-axis. And the 0 tells me that I don't count up or down, I simply stay in this position. So I put this right here. Then this locates the point, that's it. So where those grid lines meet, right there, I'm going to zoom in a tiny amount. You see where those grid lines meet? That's the point 7, 5, 0, as you see right there. That's one possibility. Take a look at the next possibility. This is another plane right here. And that plane, as you can see, you can travel up the z-axis. It's 1, 2, 3, 4, 5, 6, 7, 8. That's the z-coordinate from that axis. That there is the y-coordinate. That's the y-axis. So when you are in this plane right here, where the camera is looking, the value of the x-coordinate is 0. If you have trouble seeing that, look at it from this perspective. Look, see that? It's meant to basically be very thin. I hope you can see that. I'm going to take my ruler and I push the ruler right up against it. See that in that position? So that plane where the edge of the ruler is located right now, you see that the x-coordinate there is 0. Right where the ruler touches the plane, the x-coordinate is 0. And that is so for any position in this plane. You see? The x-coordinate is always equal to 0 right here. So for that reason, when I label a point here, I'm going to do it this way. Take a look. Let me turn this. And I'm going to do this point right here. Let me grab it. The point 0, 6, 5. So the x-coordinate is 0, the y-coordinate is 6, and the z-coordinate is 5. We can just count off. Take a look. So begin from the origin and then count 6 along the y-axis. And then the 5 tells you count 5 straight up. So I do that, 1, 2, 3, 4, 5, and then the point is right here. Okay, that's the point in that position. I'm going to change the camera view a little bit so you can see it better. I'll leave it there for a second. So 0 along the x-axis, 6 along the y, and 5 along the z. And that's how you do that portion. Let's do one last plane. So the last plane, as you can see clearly, is this plane. When I look at this plane, we call this the xz plane. And obviously it's called that because that there is the z-axis going up. And then on the bottom we have the x-axis going in that direction. And then any other point can be labeled as a combination of x and z. Take a look. From this perspective right here, remember this is meant to be an infinitesimally thin sheet. In other words, there is no what we would call y-coordinate in this plane. See that? Look at the ruler edge. If you have trouble understanding that, you see how the ruler edge is right up against that surface everywhere? That means you're not going in this direction, correct? You're not doing that. You're not going away from this plane. So within this plane, anywhere, the way you see here when I'm up against it, that means the y-coordinate is equal to 0. If you have trouble, take a look. Put that at the origin itself in this position. See, I'm moving in this plane where the edge meets the plane. So that is obviously a y-coordinate of 0 anywhere there. So when I locate points here, this is what I do. Take a look. This is a point I want to locate. It's got coordinates 4, 0, 5. X is 4, Y is 0, Z is 5. So I'm going to count off 4 along the x-axis. 1, 2, 3, 4 along the x-axis. Again, I need to move this. You can see in 3 dimensions. 4 along the x-axis, 0 along the y-axis, and then 5 straight up this way. Up to here. You see? And then I pinned this in that position. So that is the point 4, 0, 5. Let me zoom out on all of the points so you can kind of see all of them at play. If you need to, please pause the video, right? Look through them carefully. And by points, I mean like the tips of the arrows on each little thing that I put in there. This is the view from this plane. This is the view from that plane. And that there is the view in that plane. I can also obviously turn this, right? I can show you the view this way in this plane. This is the XY plane, and it looks as shown here. All right, that is it for this one. These are the major ways of locating points in different coordinate planes. Thank you so much. Please leave a like and subscribe. In another video, I'll give you a more kind of general introduction in the sense that I also talk about locating points here within this 3-dimensional space. Thank you, and I'll see you in another video.